For question 1, I'll convert the fractions into improper fractions. So left hand side equals to 15 over 4 times 7 over 9. And now I can simplify the 15 with the 9. I've got 5 and 3. So I get 35 over 12, which is equal to 2 and 11 over 12 as required. For question 2, I'll need to open my compass to a length less than BC and draw an arc that cuts both lines BA and BC, something like this. Note that I'm interested at the 2 points of intersection of the red line with the lines AB and BC, so some students prefer to draw 2 separate arcs like this one. Next step is to draw 2 separate arcs with these 2 points as the center, where they will meet somewhere here. Note that when drawing the 2 blue arcs, you should not change the radius of the compass. It should be exactly the same. And then in the final step, join B to this new point of intersection using a ruler. In part A of question 3, since I have multiplication, I will add the 2 powers, so I'll get h to the power of 9. In part B, I need to substitute c equals minus 5. Let's show the substitution. G equals minus 5, the whole thing squared, minus 4 times minus 5. This is equal to positive 25 plus 20. So the answer is 45. Now you can solve the substitution and then put everything on the calculator to get the answer. And then in part C, I'll start by cross multiplying. So 5x minus 3 equals 2, 4 times 2x plus 3. So 5x minus 3 is equal to 8x plus 12. Let's take all the x's to the right, so 3x, and then minus 3 minus 12 on the left will give me minus 15. If I divide everything by 3, I will get minus 5. In question 4 part A, the model class is the class with the highest frequency. This is the highest frequency, so this is the answer for part A. Let's write this down. For part B, I need to find an estimate for the mean length. Now, whenever I have a frequency table, the mean is given by sigma fx over sigma f. Now, the total of the frequencies is 60 because I have 60 students. You can verify this by adding the frequency column. Now, to find sigma fx, I'll need to multiply the frequency, that's my f, by x, and because I have intervals, I'll need to find the midpoint of each interval. Let's add another column, and that's my x value, so the midpoints are 5, 15, 25, 35, and 45, and then I'll multiply f by x, so another column is required. 4 times 5 is 20, 10 times 15 is 150, and so on. Let me complete this column, and when I add these numbers, I'll get 1690. That's my sigma fx. So let's go to part B again. 1690 over 60, and this will give me 28.2 to 1 decimal place. For question 5a, I'll use 2 methods to solve this question. So for method 1, I will first find the actual increase, which is 8265 minus 7500. This is 765. So now the percentage increase is the actual increase over my original value times 100, and this will give me 10.2. Now the second method involves the multiplying factor, and we know that the original value times my multiplying factor gives me my final value. So the multiplying factor is equal to the final value over the original value, and in our case we've got 8265 over 7500, and this comes out to be 1.102. If you think of this as a fraction with a denominator of 100, it's going to be 110.2, which means there's an increase of 10.2 out of 100, and this gives me my answer. For part B, I think the easiest way to proceed is to work with the multiplying factor. I have a reduction of 30%, which means my multiplying factor is 70 out of 100, because from 100 to drop 30 you go to 70. This is 0.7 as a decimal. So using the formula that I've mentioned above, original times multiplying factor is equal to the final one, I get original times 0.7 is equal to 3150. So the original price is equal to 3150 over 0.7, which will give me 45 euros. For question 6, first recall the formula for the midpoint. That's the mean of the x-coordinates and the mean of the y-coordinates. So let's work separately for the x-coordinates. Minus 3 plus 47 over 2 is equal to a. So a comes out to be 22. And then we will work with the y-coordinates. 11 plus b over 2 is equal to minus 19. So 11 plus b is equal to minus 38. So b is equal to minus 49. So 22 and minus 49 are the two missing values. For question 7, I'll need the distance, speed, time triangle, which basically says that if I want the distance, then hide the distance, that's speed times time. If I want the speed, this is distance over time. If I want the time, that's distance over speed. So for Pedro, we have distance equals to speed times time. The speed is 90 and the time is 2 hours and 42 over 60. Remember, that's not 2.42 but 2 and 42 out of 60. There is a button for mixed fractions on the calculator, so this will give you 243 kilometers. Then for Janine, we need to find the speed. This is equal to distance over time. Now the distance is the same as Pedro, so 243 divided by 3 hours, so this will give me 81 kilometers per hour. In question 8, I have an increase of 8% per year, so my multiplying factor is 108 over 100, that's 1.08. Now I've got 3 years, so I'm gonna take my original value, that's 1200 times my multiplying factor to the power of 3 because it's 3 years. So this will give me an answer of 1512. In question 9, I have a box sitting on a table. The face in contact is the blue one. This is a square of side 1.5 meters. And I know the pressure. I want to find out the force. So I'll start by finding this blue area, which is 1.5 times 1.5. This gives me 2.25 square meters. So the pressure, that's 34.8, is equal to the force over the 2.25, which means that the force is the product of the pressure and the area. This comes out to be 78.3 newtons. In question 10, I'll start by adding 3, 2, and 5, which will give me 10 parts in this ratio. And then I'm going to work separately for the chocolate, lemon, and fruit cakes. Now 3/10 of 80 is equal to 24. So the total number of chocolate cakes is 24. All of them are sold. So 24 times 2 pounds will give me 48 pounds. Then for the lemon cakes, 2/10 of 80 are the lemon cakes made, but only 3/4 are sold. So I've got 12 lemon cakes. Each one is sold at a price of 170, so the amount received is 20.40. And finally for the fruit cakes, 5/10 of 80 is the number of fruit cakes made, times 7/8, which is the number sold, that's 35. 35 times 240 will give me 84 pounds. And then in the final step, I will add these 3 numbers. So I get 48 plus 2040 plus 84, and this will give me 152.40 pounds. For part A of question 11, I need to complete the cumulative frequency table. Now for the first group, I will have 9. Then the second group is 9 and 19, which is 28. Then the third one is 9, 19, and 17, so that's 28 plus 17, which is 45, and so on. So the missing values are 63, 76, and 80. In part B, I need to draw a cumulative frequency graph. Now for this graph, my x coordinates will be the upper bounds of the age, and the y coordinates will be the cumulative frequencies. Note that the lower bound of the first age group is 0, so this will be my x-intercept, so the graph will pass through 0, 0. So let's go to the graph. I'll zoom out and plot all the points. And now I will join the points either using a smooth curve or individual like segments using a ruler. I'll do the second one. Then in part C, I need to find an estimate for the median. I've got a frequency of 80. If I divide this by 2, I get 40. So I want the 40th observation. So I'll go to my graph and I'll go on the 40 on the cumulative frequency, find the corresponding x value, and that is the median. So the value on the age axis is 37, and this is my median. Note that the mark scheme accepts any value between 35 and 38. For question 12, I will solve the simultaneous equations by using the method of elimination. I'll multiply the first one by 5, the second one by 2, so I can eliminate the y's. So I get 35x plus 10y equals to 27.5. And for the second one, 6x minus 10y is equal to 34. Since the y's got the opposite sign, I will add, so they cancel out. I got 41x equals to 61.5. So x is 61.5 over 41, which gives me 1.5. And then I will replace x into any of those 4 equations. I'll go with the first one. So 7 times 1.5 plus 2y is equal to 5.5. So 2y is equal to 5.5 minus 7 times 1.5, which gives me minus 5. So y is minus 5 over 2, which is minus 2.5 as a decimal. So the two answers are 1.5 and minus 2.5. Question 13. To differentiate, I will multiply the coefficient with the power. So we have 15x, and then we reduce the power by 1, so I get squared minus, then note here the coefficient is 1, so 1 times 2 is 2. I've got 2x to the power of 1, no need to put it, and then x here has a power of 1, so minus 6 times 1 is 6, x to the 0, so this is 1, plus 4, which becomes 0, so this is my answer for part A. Then for part B, I need to find the 2 points where the gradient is 0. I will set the value of dy dx I found above to 2, and this is a quadratic equation that I need to solve. 15x squared minus 2x minus 8 is equal to 0. That's how we solve quadratic equations. I'll try with factorization. 5x minus 4 is the first bracket. 3x plus 2 is the second one. Now you can use any other method here. X comes out to be 4 over 5 from the first bracket, or x is minus 2 over 3 from the second. And these are the two x values which are required. In question 14, I'll keep the first bracket as it is, and I'll expand the last two. So I get 5x squared plus 6x minus 15x minus 18. Let's simplify the second bracket. 5x squared minus 9x minus 18. And now let's expand 20x to the power of 3 minus 36x squared minus 72x plus 5x squared minus 9x minus 18. And if I simplify, I will get 20x cubed minus 31x squared minus 81x minus 18, which is my final answer. For question 15, there are many methods to show that the tangent is parallel to the line EF. Now I'll start by finding BDF, which is this one. This is 70 degrees because of the alternate segment theorem. Then I'll find angle BFE, which is this one, and to find this one I'll do 180 minus this angle because these 4 points create a cyclic quadrilateral, and opposite angles in a cyclic quadrilateral add up to 180. And finally, note that this angle here, which I just found to be 70, is equal to this one. Hence, I've got alternate angles, so the lines are parallel. For part A, I want the value of x that makes the denominator of g 0, and this is equal to -4. Then in part B, I will first calculate f of 2.6. This is equal to 5 times 2.6 minus 7, which is equal to 6. And then I will do g of 6, which is 5 times 6 over 6 plus 4, which comes out to be 3. Then in part C, I want fg of x. To get this, I will take my g function and use it as an input in the f function. So I will get 5 times 5x over x plus 4 minus 7 is equal to 2. Now I'm going to expand this. Note 5 outside the bracket is like having 5 over 1. So I get 25x over x plus 4. And then the minus 7, I can take it to the other side. So it becomes 9. Then I will cross multiply 25x is equal to 9x plus 36. So 16x is equal to 36. X is 36 over 16, which comes out to be 9 over 4. In part D, I want to find the inverse of g. So take the g function, assume we've got y is equal to the right hand side. So y equals 5x over x plus 4. The inverse interchanges the roles of x and y, so I get x equals 5y over y plus 4. And now I'll need to make the new y the subject. I will cross multiply. Xy plus 4x is equal to 5y. I'll take the y's on the same side. So 4x is equal to 5y minus xy. I will factorize y equals 5 minus x. And finally, to get y on its own, I will divide by the bracket. So 4x over 5 minus x. And this is the inverse function. So let's write it at the answer space. And we're done. In question 17 part A, I will need to work out this angle here. So I'll need this triangle whose base I don't know, but I can find using half of the base of the shape. So let's color code the required triangles and let's extract them to part A. So from the red triangle, I have FH squared is equal to 12 squared plus 12 squared. So FH is the square root of the right hand side, which comes out 12 root 2. Let's put this here. And then I can find the missing angle by using tan of F equals opposite over adjacent. So F equals inverse tan of this number, and this will give me 30.5 degrees to 1 decimal place. Now, for part B, I will need to find the side BE, which is this one. Now, let's clear the two triangles. So, to find BE, I will need the following triangle. Now I know the base of this triangle, that's 12 square root of 2, but I don't know the height. The height is 10 plus some extra, so I'll need this triangle. Let's shade this as well. So using the orange triangle, I'll find this extra height, and then I'll be able to find the side BE. So let's copy this triangle to part B. So using the orange triangle, let's call this side X. So 15 squared is equal to X squared plus 12 squared, which means X squared is equal to 15 squared minus 12 squared, which implies that X is equal to 9. Hence, the height of this triangle BG is equal to 9 plus 10. 10 because this side is equal to 10. So I get a height of 19. And then for B, I'm going to use Pythagoras again. So I've got 19 squared plus 12 square root of 2 squared. BE comes out to be 25.5 centimeters. In question 18, I will need the following two formulae for arithmetic series: the nth term and the sum of the first n terms. Now I'm given two pieces of information. I'm given that the sixth term is equal to 39, so 39 equals to a plus 6 minus 1d, which means that 39 is equal to a plus 5d. And I am also given that the 19th term is equal to 7.8, hence 7.8 is equal to a plus 19 minus 1d. So 7.8 is equal to a plus 18d. And let's solve this simultaneously. I will subtract, the a's will cancel out. 39 minus 7.8 is 31.2. 5d minus 18d is minus 13d, which means that d is equal to minus 12 over 5. And if I use the blue formula, I get 39 is equal to a plus 5 times this minus 12 over 5. If I solve for a, I will get a is equal to 51. So now I can use the sum formula. S, or sum, is equal to 25, because I want sum of the first 25 terms, over 2, and then I've got 2 times 51 plus 25 minus 1 times my difference. And if I put this on the calculator, I will get 555. For question 19, let's start by putting this on the diagram. Next step is to find the upper and lower bounds of these lengths. For AD, the lower bound is 8.25, upper bound 8.35. For DC, lower bound 7.15, upper bound 7.25. For EH, lower bound 6.15, upper bound 6.25. And finally for HG, lower bound 5.25 and upper bound 5.35. Now I need the upper bound of the area of the shaded region, so the maximum shaded area is given by the maximum of the area of the big rectangle minus the minimum area of the small rectangle. Now, to get the maximum area of the big rectangle, I will need the biggest of the length and the width of this rectangle. And to get the minimum area of the small rectangle, I'll take the smallest possible dimensions of the small rectangle. So I get 8.35 times 7.25 minus 6.15 times 5.25. And if you put this on the calculator, you will get 28.25. For question 20, I'm given the coordinates of the only maximum point of this curve, and I need to find the coordinates of the maximum of f of x minus 6. Now recognize this as a translation of 6 units down. Hence, I will subtract 6 from the y coordinates, so the x coordinates stay the same, the y coordinate becomes minus 2. For part II, recognize this as a stretch along the x-axis by a scale factor of 1/2. So I will divide the x coordinate by 2 and get minus 3/2 and keep the y coordinate the same. For question 21, note that I can write 18 as 2 to the power of 1 times 3 to the power of 2, and I can write 12 as 2 to the power of 2 times 3 to the power of 1. Next, I will replace these values in place of 18 and 12, and I will also replace them by 2. So 2 to the power of 1 is equal to 2 to the power of 1 times 3 squared to the power of 4n times, and now let's expand this bracket, 2 to the power of 3n squared minus 18n times 3, and I will also expand this bracket, so I get 2 minus 8n, and in the denominator I have 2 squared times 3 to the 1 all to the power of 2. Now I will proceed by multiplying this by 4n and these powers by 2. So let's move down. 2 to the power of 1 is equal to, and we get 2 to the power of 4n times 3 to the power of 8n times, and then the rest stays the same. And then in the denominator, I get 2 to the power of 4 times 3 to the power of 2. Now, I will proceed to simplify the numerator of the right-hand side. I can do so by adding the powers of 2 and also adding the powers of 3. So 2 to the power of 3n squared minus 14n times 3 to the power of 2, and then the denominator stays the same. Now note that I can cancel out the 3 to the power of 2, and I'm left with only powers of 2. Because I have division, I can subtract these powers. So 2 to the power of 1 is equal to 2 to the power of 3n squared minus 14n minus 4. And now, because I have 2 to a power equals 2 to another power, I can equate the two powers. So 1 equals 3n squared minus 14n minus 4. This is a quadratic. I'll get everything on one side, and then I'll factorize 3n plus 1 n minus 5. Hence, n is equal minus 1/3, or n equals 5, and these are my two answers. In question 22, there are many ways to split the shape and find the area. The method I have chosen is the following. Now note that this is a regular octagon, which means all sides are equal. Now consider the following lines. The four triangles in the corners are isosceles triangles, and I will use this to find the two perpendicular sides. So using Pythagoras theorem, x squared plus x squared is equal to 10 squared. So 2x squared is equal to 100, x squared is equal to 50, x is equal to the square root of 50. So let's go back to the shape. Hence, the length of my blue rectangle is 10 plus 2 times square root of 50. And this is also the base of the red triangle. And furthermore, the height of the red triangle is square root of 50. So let's extract these two shapes. So the area of a rectangle ADEH is equal to 10 plus 2 square root of 50 times 10, which is equal to 241.421 and so on. And the area of triangle ACD is equal to 10 plus 2 square root of 50 times the height, which is square root of 50 divided by 2, which comes out to be 85.355 and so on. So the total area is equal to the sum of these two numbers, 241.421 plus 85.355, and this comes out to be 327 centimeters squared to the nearest integer. For question 23, I've got 3 blue, 4 white and X orange beads. So in total, I have X plus 7 beads. Now I can draw a tree diagram for this problem, but there's no need, as I'm only interested in 3 combinations, and the combinations I'm interested are the following: blue, blue, probability of white, white, and the probability of orange, orange, and the sum of these 3 probabilities should be 3/8. Now, to get 2 blue, I need 3/x plus 7, and because it's without replacement, I'll multiply this one by 1 less in the numerator and also 1 less in the denominator. So this is my first probability, plus I have 4/x plus 7 times 3/x plus 6. And finally, for the orange, I get x/x plus 7 times x minus 1/x plus 6. And this must be equal to 3/8. Now note, all the denominators are equal. That's a product of 2 terms. So I can add the 3 probabilities. So x plus 7, x plus 6 will be my denominator. And then the numerators are 6 from the first bracket, 12 from the second, and x minus 1 from the third one. Again, this is equal to 3/8. Now I will expand the denominator and simplify the numerator. So I get x squared minus x plus 18 for the numerator over x squared plus 13x plus 42 for the denominator. again equals to 3 over 8. So now let's cross multiply. 8x squared minus 8x plus 144 is equal to 3x squared plus 39x plus 126. If I take everything to the left hand side, I will get 5x squared minus 47x plus 18 is equal to 0. I can factorize this. 5x minus 2 times x minus 9 is equal to 0. So x comes out to be 2 over 5, or x is equal to 9. Now x is the number of orange bits. It cannot be a fraction, must be an integer. So I will reject the 2 over 5 and keep the 9. The question says find the total number of bits. So from x equals 9, the total is x plus 7. So I get 9 plus 7, which is equal to 16 bits, which is my final answer.